Here we are at the last lesson of the unit, and what we're going to do is put everything together. We've kind of done this before in the last lesson, but start to finish. So we're just going to work through two examples, one with Luigi and some cheese, and see one on the back. So Luigi needs to buy cheese for his restaurant. He can buy cheddar or Swiss. He must buy at least 5 kilograms of cheese in total, but his fridge can only hold 8 kilograms. If he pays $2 per kilogram for cheddar and 3 per kilogram of Swiss, how much of each cheese should he buy to minimize the amount of cheese? So again, the first step we want to do is identify the quantity that must be minimized or maximized. And this one, we want to minimize the cost of the cheese. So again, in doing these problems, it's just a matter of reading the story, and usually the very last sentence in the story is the question that needs to be answered. Then we're going to define our variables, and well, what can vary? Well, we can vary the amount of cheddar, and I'll call that X, or the amount of Swiss, and I'll call that Y. And again, we always want to use X and Y because we're going to graph them, and away we go. Then, based on the other sentences, we want to write our inequalities. Well, here's what we know, and again, if you just read the sentences, you can just list them. So our first sentence is he must buy at least 5 kilograms of cheese in total. So that's what this says. He has to buy at least 5, but his fridge can only hold at most 8. So that's the first two. And then, well, we have to buy some of each. And again, X and Y can be, well, they can be part, right? So they could be decimals. So we have to make sure we have to understand that they're real numbers. So our objective function is the cost of the cheese. That's what we want to maximize or minimize. And the cost of the cheese is equal to how much it's going to cost for your cheddar. And it's going to cost you $2 for every kilogram of cheddar, and it's going to cost you $3 for every kilogram of Swiss. So this is our function that we need to minimize. And again, the way we figure out what should go for X and Y is we sketch the system, and we look at the corners because that's where things can be maximized or minimized. So I'm just going to sketch these two right here, because X comma Y greater than 0, that just means everything has to be above the X-axis and everything has to be the right of the Y-axis. So here's our X plus Y is greater than 5. We go ahead and we graph that line, and that's what that looks like. And X plus Y is less than 8. We graph that one, and that's what it looks like. Now again, I'm not going to talk about how I did it. We've graphed enough lines now that we should be able to figure it out. Now, everything in here is our feasibility region. All of these answers would make sense. But as we learned the other day, really what it comes down to is it comes down to these 4 points. So again, I'm going to label this point number 1, point number 2, point number 3, and this will be my point number 4. And if we can figure out the values of our objective function at these 4 corners, we're going to find one of them is going to be the maximum amount for cheese, and one of them is going to be the minimum. So I'm going to go ahead and I'll just call it 1, 2, 3, and 4. And I'm going to plug in the numbers. So C is equal to 2 times 0 plus 3 times 0, which is equal to, 3 times 5, right, which is equal to 15. So our first one is 0, 5, and our second one is 0, 8. So our cost is equal to 2 times 0 plus 3 times 8, which is $24. Our next point is 8, 0, so the cost is 2 times 8 plus 3 times 0, and that's equal to 16. And our final point is 5 comma 0. So we have 2 times 5 plus 3 times 0 is equal to 10. So here is the minimum amount of cheese he would have to buy to fit the criteria. So if he buys 5 cheddar, 5 kilograms of cheddar, and 0 kilograms of Swiss to minimize his cost. Minimize the cost. So again, we're just summing up everything we've done over the last couple of classes. Well, here's another question where somebody's going to mix juices together, and what we're asked to do is how can Betty get the most vitamin C in her punch, given that orange juice has so much vitamin C and grape juice has so much vitamin C per kilogram. Then we want to maximize the amount of vitamin C. So again, whatever that last question, this is always your starting point, right? Usually getting started is difficult, but if you identify the quantity, which is usually what the question asks. So again, the amount of vitamin C, that's what we want to maximize. And I'm just going to call it A for amount. Now, what can change? Well, what can change is the amount of vitamin C in orange juice. So I'll just say the amount of orange juice. And Y would be the amount of grape juice. So if you change the amount of orange juice, you change the amount of vitamin C in that orange juice, and same with the grape juice. So what would our inequalities be? So again, we just go ahead and read off the sentences. Her jumbo punch bowl holds 9 liters of juice. So first of all, this is the most you can have in the punch bowl. It has to be less than or equal to 6. And Betty has 6 liters of orange juice, so that's the most she can use. 1 liter, 2 liters, 5 liters, 2.6 liters, whatever. And she has 7 liters of grape juice, so she can use 0, 1, 2, 3. But as I just said, notice I haven't set any negative numbers. So again, the amount used has to be greater than 0, and X and Y can be decimals. You don't have to add 1 liter, you can add 1.6 liters. And finally, when we go ahead and write our objective function, again, the objective function comes from this statement right here. So this is how much vitamin C is in 1 liter of orange juice, and that's how much vitamin C is in 1 liter of grape juice. So again, our objective function would be the amount of vitamin C is equal to 2 times the number of orange juice plus 1 times the amount of liters of grape juice. And again, in order to figure out the X and the Y that's going to maximize that or minimize it, depending on what we want, we have to write our system. So X plus Y is less than or equal to 9 is simply this line right there. And X is less than 6, I'll use this one, is, remember, it's a vertical line, and it's facing that way, but it also has to be greater than 0, so it's in between right there. And let me do my Y is less than 7, and again, greater than 0, it's going to be over here. So our feasible region is going to be this region right here. But as we know, we don't care about the inside. There's an infinite amount of answers on the inside. What we care about are the corners. So in this one right here, if we want to maximize the amount of vitamin C, it's one of those quarters. And this one right here, I'm going to totally disregard because Obviously, the answer is 0. So let's look at, let's call this coordinate 1, coordinate 2, coordinate 3, and coordinate 4. And we're going to check these 4 points for the amount of vitamin C that would generate based on that. So 1, 2, 3, 4. So point number 1 is 0, 7. Point number 2 is 2, 7. Point number 3 is 6, 3. And point number 4 is 6, 0. And again, I'm just going to substitute those into the objective function above for x and y, except I'm just going to write the amounts. So that would be 7, that would be 11, that would be 15, and finally this one would be 12. And based on that, this is my combination: 6 liters of orange juice and 3 liters of grape juice. That will maximize the vitamin C. So in a sentence, using 6 liters of orange juice and 3 liters of grape juice will maximize the amount of vitamin C.